Hello everyone! In this video, you will learn about different measures of similarity and dissimilarity. These measures are used to perform clustering in unsupervised learning. Together, we will go through some typical measures of this similarity and dissimilarity and their mathematical definitions with some visualization. After watching this video, you will be able to understand different measures of similarity and dissimilarity in clustering. So let's start with a typical clustering problem using two features, x1 and x2. In this 2D feature space, we want to determine if the data samples are similar or dissimilar to perform the clustering analysis. So how do we determine whether two samples are similar or not? The answer is that we must use a measure for similarity or dissimilarity. One of the options is to use what is called cosine. In this measure, that considers the angle between two vectors, and you might be familiar with this definition from the courses of linear algebra. For explanation purposes, let's consider the plot three different points, x1, x2, and x3. And over here, you see theta 1, 3 is the angle between the vectors from the origin to x1 and x3. And we can also calculate the angle between the vectors of x1 and x2. And that is called the theta 1, 2 shown in the plot. Then we compare the two angles, theta 1, 2 and theta 1, 3, and it appears that both angles are quite similar to each other. So in that sense, we will say that x1 is similar to both x2 and x3. Now, if we consider the normalization of the data samples or a different origin for the vectors, then maybe the cosine similarity would provide some more information. Here you see the angles between the vectors of the samples. Now theta 1, 2 and theta 1, 3 are sufficiently different from each other, meaning that the samples can be treated as dissimilar. We can also quantify the dissimilarity between two data samples. A classical measure is using the Euclidean distance. In this case, it is the pairwise distance between the two data samples, also known as the distance between two vectors. In the plot over here, you can see two clusters, C1 and C2. In red, we highlight one data sample in cluster C1 just for explanation purposes. We can calculate the distances between this sample to other samples in the same cluster. And we want to have the calculated distances as short as possible, so we can group the samples into the same cluster. In this plot, you can see now the distance from the red sample to members of other cluster, C2. In this case, it is actually a good property because we want the samples belonging to the other clusters to be as far away as possible from the red sample. Here, we are analyzing an important and sensitive property about where we define the boundaries between clusters. In this plot, you can see when the data samples are near the boundaries of clusters. They are going to be closer to the members of the other clusters than to the other samples in the same cluster. So we need to pay attention to how the boundaries between clusters are defined and how they are going to affect the clustering results of different algorithms that you might use from the literature. You can also find other options to measure dissimilarities. For instance, the L1 and LP norms and L infinity. These are all different measures of distances that would lead to different characteristics of clustering analysis. So here let's take the two red dots as an example to demonstrate the different distances. This is the Euclidean distance as we defined it before. In this plot, we can see the L1 distance. This is also called the taxi curve or Manhattan distance. In this plot, the sum of the two lines is the LP distance, which is somewhere in between of L1 and the Euclidean distance. And finally, the L infinity distance captures the maximum distance with respect to all the components of the vector. There are also measures of dissimilarity using non-vector inputs in real-world applications. A function d using xi and xj as input can be tailored to compute the dissimilarity between text, news, images, audios, videos, etc. Overall, the selection of similarity or dissimilarity measures will determine the results of the clustering problem. The optimal measure is usually related to the application, so the inherent characteristics of the data that we are dealing with. In this video, we will learn about typical similarity and dissimilarity measures, including cosine, different metrics of distance, and dissimilarity functions, with non-vector inputs. Clustering results rely on the choice of similarity or dissimilarity measure, and we should understand that the optimal choice usually depends on the inherent characteristics of our clustering problem and data.